here. My name is Jessica Nguyen, and I'm a quantitative researcher at Meta. I'm based in San Francisco, California, but before then I was at Wharton. It's nice to be back to see some familiar faces again. Today I'm going to be talking about using simulated data to validate marketing mix models. And the whole purpose of this is just to offer you additional tools in your arsenal to think about your marketing mix models. How can you actually be sure that you can trust your results to make business decisions? And I'm going to be doing that in 3 parts. First, I'm going to be talking about our oldie but bestie keeps coming back again, MMMs. Then I'm going to be talking about why it's so difficult to actually validate, some of the challenges associated with that, some of the methods. And then I'm going to be talking about one method in depth that you should consider, which is using simulated data. And I also want to shout out to the MSI MMM initiative, which I think this could be a part of, just one way that they might consider doing that. Cool, so just to set the bar, everyone probably knows what MMMs are. We talked a lot about them yesterday, so I'm not going to go super into depth, but they've been around for decades. For a while, kind of went away. We had other data, and we were like, oh, that's cooler. Let's do something else. But of course, recent conditions, regulations, changes from platforms have moved us back towards a resurgence in MMMs. And a lot of these privacy concerns make it really hard to collect granular data like we had before. And so MMMs are good to get around this because they're built usually on aggregated level data, which isn't, privacy concerns don't impact. There's also been increased concerns over causality of other methods that have been used in the past because of these privacy concerns, so another reason why MMMs are really coming to the forefront. And finally, it's been really exciting, but over the past 5 years, I think there's been a lot of innovation into MMMs. We can build them a lot faster than we used to build them. We can rely on machine learning to aid in building our MMMs. Like now, I can't even remember, but I feel like we can build like hundreds of models at a time just really easily. So another reason why MMMs are coming back. Okay, so while MMMs are commonly used, they're actually very hard to validate. And by validate, I mean, how can we trust our results? How can we make sure that our results are accurate? And well, there are a lot of reasons why this is very difficult. I'm just going to be talking about 3 of the main reasons here. The first is this issue of ground truth data. And by that, I mean, what data do we use to compare our predictions to ensure that they're accurate? With MMM, we usually have sales level data as our dependent variable. But most of the time we build MMMs not because we want to predict sales, but because we want to predict the ROIs of our advertising channels. And that we do not have, which is probably why we built the model in the first place. But what are you going to use to compare the predictions to in this case? The second reason is because it's built off of time series data. So time series data, very difficult because past predicts the present, predicts the future. And so even if you were to pick a holdout group, you like randomly pick rows, do you keep the time series nature of it together, but then what do you use for the holdout period? You can get really different results depending on how large you make the holdout period to be. And so then you kind of run into the problem of, what do we do now? Major problem. Finally, it requires a lot of data. A lot of advertisers build their models at a weekly or monthly level. Sometimes I see daily, that's getting more common, but it's still a little bit rare. And so if you're a smaller advertiser and you don't have a lot of data, maybe you've only been around for a few years, how can you actually have enough data to not only build a model that you can trust in, but then have enough data to validate it? So these are just some of the really large challenges that we see with validating MMMs. There are several methods that people can use to validate MMMs. Of course, no method is perfect. I wouldn't say use just one method. You probably need a combination of these. But I'm going to, of course, leave it up to the MSI MMM challenge to further prescribe details on how to do that. But today I'm just going to be briefly mentioning some methods. So the first one is really common. It's called backtesting. We just split our data into a training, testing set, keeping the time series nature of the data together. As you can probably already tell, there's some limitations to this. The first one being our dependent variable is going to be sales, not ROIs. And so we're going to be seeing how well our model predicts for our sales. And if that's what you care about, then this is a fine method. But if you care about ROI, then maybe not. The next method is calibrating with experiments, which is really cool because you go into the wild, you run an experiment, and then you go back to your model and you see, okay, well, how well does this line up? Is this roughly what we got from our MMMs as well? And this method is really good because these experiments are usually RCTs, randomized controlled trials, and so really rigorous. Of course, they have their own problems too nowadays with privacy concerns, but generally we consider them to be really good, and it's also based in real life, so no. But they are less common, and it's very difficult to run. First off, they cost quite a bit of money, and if you're a smaller advertiser, you don't really have enough money to run them. Also, they take quite a long time to run, and a lot of advertisers we see might only run them like every 6 months or so, very periodic. And maybe you want to build your MMM much faster than that, so that's a challenge there. Lastly, I'm going to be talking in depth today about simulated data, which is my favorite of these methods, just because I'm a stats nerd. And what you basically do is you make some assumptions, you add some statistical noise to it, you come out with this simulated fake data set, you plug it into an MMM, you see what the MMM spits out. Now you know exactly what the ROIs of the data set should be because you made those assumptions in the first place, you set them. And so then you're just seeing, okay, how well can the model recover our assumptions? And if it's a little confusing, then that's okay, because it was confusing to me at first too. I'll go into it in more detail. But first, again, please consider contributing to the MSI MMM initiative. I think that initiative is really going to expand on our toolbox, maybe bring these different tools together, provide a framework for how to think about validating models. And yeah, I would highly encourage everyone to participate if they can. It's a great group. We've been having a lot of great discussions, getting insights. So yeah. Okay, with that, let's talk about what simulated data is. And in essence, it's fake data. I'm just making it up. There are different ways that you can think about simulating data. Perhaps the first obvious way is you already have data, and then you just inject it with some noise, and then poof, you get fake data. That is one way to do it. Another way is more like building it from the ground up. And so let's make some assumptions here. Let's inject it with some noise and then put it into our MMM. The second way is actually how we should be thinking about it for MMMs, because we care about recovering the ROIs and the assumptions that we put in, whereas the first way, we're not going to be able to do that. So I'm going to be talking about the second way today. Why is it useful? I've already alluded to this, but since we created the data, we know exactly what the answer should be. Interestingly, I found out about using simulated data, and I was inspired by people in astrophysics who had really complicated models, and they could never really test it out because experiments are, I guess, infeasible on an astrophysics scale. So I actually borrowed from that, but people also use it in computer science, very basic. Say you have some sort of algorithm to count the number of E's in a sentence, and so you generate some simulated data. In this case, my sentence, the cow jumped over the moon, and since I simulated it, I know exactly how many E's should be in it. I plug it into my algorithm, and poof, an answer. So by that, I'll know, did the algorithm work as intended? And yeah. So for MMMs, we're going to be applying roughly the same principle, but on a much larger scale, a little bit more complex. And so I actually was inspired by a class I took here at Wharton, and I'm not what the class is. But I'm going to be basically simulating the advertising story. How does advertising work? So I'm just taking a very simple approach here. First, you have baseline sales, or sales when there's no advertising. Okay, and then you spend some money on some ads, and that leads to some impressions or clicks. In this case, when I'm calling media variables, a proportion of those become conversions, and then we, of course, have to apply our good marketing theory, diminishing returns, ad stock, etc. And then finally, we get the ROIs, and we know exactly what the ROIs are because we mathematically set them. And as we're going along here, we make different assumptions, we inject noise. So, for example, step 2, ad spend. let's say you spend $100,000 on average a month on your advertising. Sometimes you spend a little bit more, sometimes you spend a little bit less. You can add however much noise you want to add to it. For the stats nerds in the room, I'm just using like a normal distribution. I'm asking you what the mean and the standard deviation is, and that's kind of how I'm simulating all along these. I just assume different distributions that fit. And this is really useful because first we can see if our MMM spit out what we put into it. And that allows us to do several things. We can simulate various scenarios, change things up about the story, change our assumptions and see how well our MMM responds. Maybe there's this like weird area that the MMM gives weird answers to. We can see that. We can also make changes to our MMMs and see how that influences how it responds. What's the value of that particular innovation or feature to the MMM? Okay, so you can do this yourself. Like you yourself could open they have like the probability distribution Bibles, I think, and you could just like sit there and code it if you want, if that's your passion. Well, it was my passion, so I did that for you already. And so I wrote an R package. It's open source, free. You can look at the code yourself. It's on GitHub. Anyone can look at the code. And it basically just follows through this waterfall process, and in the end you get an aggregated data set that you can put into any MMM that you would like. There are various inputs that you can change. You can change baseline sales, how it grows over time. You can inject seasonality if you want. You can change assumptions about the efficiency of a given advertising channel. You can like set the CPM or CPC. You can set the conversion rate, and then you can also set how much you want to spend on each campaign. Possibilities are endless. Whatever you want. Depending on how you set your assumptions, you can get various looking data sets. For example, the one on the left has a lot of seasonality, the one on the right doesn't. And so you've already probably figured it out. There are some limitations, of course, to this method. The first question we always get asked is, how do you know your simulated data is realistic? Excellent question. We don't. It entirely depends on your domain knowledge and how much you can set the assumptions to reflect reality. If you don't put in realistic assumptions, you're probably not going to get realistic data. But I'm hoping, again, that the MSI MMM initiative can create benchmarks. And then, lovely, we have something to at least compare to. I would say my one suggestion on this is maybe you can try to recreate your historical data. And if you can roughly recreate it, then it's not the best, but probably a good thing. The second is that it's very limited advanced features. Advertising, super complicated. You can do interaction terms, for example, or like some weeks or media is on and off, but that's not built into the code package yet. It is open source, so if anyone wants to help me write the code for that, please do reach out. Like I said again, you can visit the GitHub, the website. There's also a Facebook group that I and a few other users are on as well. And I also wanted to mention another tool. It's also free open source, also from Meta. Just in case you don't have an MMM and you don't know where to start, we do have open source code to build an MMM. It's called Robin. It is supported by machine learning. You can use it to calibrate with experiments as well. And so really handy here. I'm not on the team for Robin though, so please don't ask me too many detailed questions, but I can definitely point you to the right people who are. It's been used a lot. I think like over 11,000 downloads since last year on CRAN. It's being used by a lot of companies as well. Just put a few case studies on here. You can peruse them yourself later. But here is the GitHub, CRAN, repository, microsite for Robin. And I think that is it. Yep. Thank you so much, and please let me know any questions that you have.